Good morning, everyone. I am Dr. Prashant Mandlik, Professor from Department of Chemistry, CCY Science College. I welcome you for this chemical handling and laboratory safety program. Today, I am going to deliver you acids and bases, their introduction, handling, and corrosive properties. Let's begin with our presentation. First of all, we will know about the acids and bases. All you all know that acids is a substance which contains hydrogen ion and gives rise to H positive ion in aqueous solution. For example, when HCl dissociate, it gives H positive and Cl negative ion. Similarly, acetic acid also produces H positive ion in aqueous medium. A base is a substance that contains OH group and produces OH negative ions. The OH negative ions are known as hydroxide ions. They produce hydroxide ions in aqueous medium. For example, the base NaOH will produce OH negative. Similarly, base NH4OH will produce OH negative after ionization. So here in diagram, we are finding when HCl is dissolved in water, it produces H positive and Cl negative ions. Similarly, NaOH produces Na positive and OH negative ions. So what are the properties of acids? We know that acids are sour in taste, but you don't need to taste all the acids present in the laboratory. In the laboratory, we find acids that they change blue litmus to red. Their aqueous solution conducts electricity because of the formation of ions, react with bases to form salts and water. The acids reacts with metals, active metals like alkali metals, alkaline earth metals, zinc, iron, aluminium, and liberate hydrogen gas by the formation of salts. Similarly, acid evolved carbon dioxide on reacting with metal carbonates. These are the properties of acids. Similarly, we will have some properties of bases. The bases are bitter in taste. Bases change red litmus to blue. Their aqueous solutions conduct electricity again due to formation of ions, and they react with acids to form salt and water. Comparison of acids and base. All we know that acids immediately react with base, particularly in aqueous medium. The aqueous medium means in water. The chemical difference between acids and bases is that acid produces hydrogen ions and bases accept hydrogen ions. A base is a substance that neutralizes acid to form salt and water. Here in this diagram, NaOH, aqueous solution of NaOH, when combined with aqueous solution of HCl, salt is formed along with water molecule. Now, acids and bases are classified depending upon their strength. They are classified as strong and weak. For example, here I have quoted some strong acids: hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid, perchloric acid. These are the strong acids. And the weak acids are hydrochloric acid, hydrocyanic acid, carbonic acid, nitrous acid, sulfurous acid, and all organic acids, for example, formic acid and acetic acid. These strong bases are very few, particularly the hydroxides of alkali metals are strong bases, for example, NaOH, KOH, namely sodium hydroxide and potassium hydroxide respectively. And weak bases are the hydroxides of other metal other than that of alkali metals. For example, ammonium hydroxides, magnesium hydroxide, calcium hydroxide, iron hydroxides, copper hydroxides, or all other metal hydroxides are weak bases other than that of the alkali metals. Acids and bases we use in everyday life. In our everyday life, we are using the compounds, chemicals, which are mostly either acids or bases. Even we are eating some food or taking some fruits. Some fruits are acidic, some foods are alkaline. So acids and bases are encountered daily in chemistry and our everyday life. Both acids and bases make the critical part and parcel of our livelihood. They play an efficient role inside or outside of our body. From the formation of food to the decomposition of any substance, acids and bases play a crucial role in our everyday life. Let's check their use in our everyday life. Here, a diagram that shows pH scale. We know that for acid, the pH is lower than 7. For bases, the pH is higher than 7. So here all the figure showing the acidic fruits or other ingredients that are acidic in nature. For example, hydrochloric acid, strong hydrochloric acid has pH 0. Then lemon, which contains citric acid, apple, banana, tomato, vinegar, all the components present in these compounds are acidic in nature. Even milk is somewhat acidic. Its pH lies in between 6 to 7. Water is neutral and its pH is exactly 7. It is because of both H positive and OH negative ions present in the water. Equal number of H positive and OH negative ions, and because of the pH of the water is 7. Some basic components we are using in everyday life are baking soda, ammonia, alkali, that is particularly used in dry cleaners, in batteries. Some alkaline batteries are also there. We are using daily soap, and even our blood is somewhat alkaline. The pH of blood is 7.6 standard pH. That our the pH of blood is in between 7 to 8. Acids used in everyday life. The first one is hydrochloric acid. Even we are generating the hydrochloric acid in our body as gastric juice. Hydrochloric acid is a strong acid and it helps in the digestion of food and change the food particles into protein in our metabolic reactions. Then acetic acid. Acetic acid is a common acid which is present in vinegar. It is popular to us, which is found in most of the kitchens. People use for the acetic acid in terms of vinegar for cooking purpose, and that is what gives the salad a delicious taste, and we are preserving pickled vegetable pickles and fruit pickles because of the acidic nature of vinegar. Then ascorbic acid, which is also known as citric acid, which is found in fruits like oranges, lemon and other citrus fruits. It is widely used as an acidifier and flavoring agent of food. Citric acids are also used in destaining the clothes. We are destain the clothes by using lemon in our daily life. So this is the structure of citric acid, which is somewhat complicated. Then carbonic acid. It is very useful acid for us because in rainy season, in summer season, when there is too hot, we would try to find something refreshing to feel relieved, like drinking soda or cold drinks. These are the carbonated drinkings which are made by adding carbon dioxide in water. When carbon dioxide is highly pressurized in water, the molecules, CO2 molecules reacts with water and produces carbonic acid H2CO3, which causes a refreshing sensation. Then sulfuric acid. Sulfuric acid is a strong acid whose single drop can cause a hollow mark in our skin. That skin burn will occur when sulfuric acid fall on our skin. Apart from its two dangerous property, it has numerous applications. The most common application is this of the sulfuric acid is found in car batteries or our inverter batteries. It is also used in making fertilizers, cleaning products and manufacturing of polymers. Iron and steel industry uses sulfuric acid to remove oxides coating. Then tartaric acid. Tartaric acid is a dicarboxylic acid. The food industry uses tartaric acid as an additive and flavoring agent. This acid is obtained mostly from fruits like grapes and is mainly used in the manufacture of wine. It is also used as a food preservative and in setting of gel or jellies that we are used in our food. The preservation of jellies is because of the presence of tartaric acid in them. Similar, along with acids, the bases used in everyday life uh, that here we are observing the figure where we are using the bases. Bases are the chemical compounds which are soapy in touch and are not usually meant for human consumption. Generally, we are not like acids. We are not consuming bases. They have a wide range of application in our daily life. Let's check some of them. First, sodium chloride. Sodium chloride is basic in nature because of the which is the combination of NaOH and HF. NaOH is strong base and HF is weak acid. So this salt is the combination of strong base and weak acid. Therefore, this salt is basic in nature. We automatically feel the first base of our day after brushing our teeth. That we are refreshing our teeth by using toothpaste, which we mostly the toothpaste mostly contains sodium chloride, which is slightly basic in nature. Then this kills the bacteria present in the mouth, which instead prepare a slightly acidic environment, which is exactly the condition of our unbrushed mouth. Our unbrushed mouth is somewhat acidic, and when we use the toothpaste having sodium chloride, the acidic nature of our mouth get neutralized by this sodium chloride component. Then sodium hydroxide. We are using sodium hydroxide in the preparation of soaps and detergents. Every day we take bath, but water alone is not enough to make us feel refreshed. We use soap to clean our body, and this soap contains sodium hydroxide as their main ingredients. Not only in soaps, all the cleaning products, including detergents and washing powders that we are using in daily life, also contain sodium hydroxide. Then sodium bicarbonate. This base is again strong base because of sodium. Actual sodium bicarbonate is the combination of sodium hydroxide, which is strong base, and carbonic acid, which is weak acid. So it is basic in nature. Sodium bicarbonate, commonly known as baking soda, in our daily life we are using the commercial name baking soda, which is chemically known as sodium bicarbonate. Baking soda is the regular item in our kitchen. People use baking soda in cooking, baking cakes, or even for frying pakoda. We are using sodium bicarbonate. Being a weak base, it is safe for human consumption. A solution of baking soda is commonly used for cleaning purpose also. It is also used as a fire extinguisher because in high temperature it releases carbon dioxide, which is the byproduct, and that prevent the carbon dioxide remove the oxygen from that atmosphere, and therefore the fire in that area can be controlled. Then magnesium hydroxide. Magnesium hydroxide is the compound that are used in antacids. We are using Digen mostly, that having magnesium hydroxide as a neutralizing agent for gastric acids. If our stomach release more gastric acids, then we feel some acidity, and in that case, to neutralize this excess gastric acid, we use Digen that contain magnesium hydroxide. They are used in antiperspirant deodorant also. Then calcium hydroxide. Calcium hydroxide, commonly referred to as hydrated or slake lime. It is widely used in cement manufacturing. It is also used in neutralizing the acidity of the soil and treatment of sewage water. Calcium hydroxide is also an additive feed in improving animal nutrition. It is also used in dental procedures. Then ammonia. Actual ammonia is gas, but ammonia is widely used as a base in agriculture, industry, and homes for the preparation of fertilizers. That that's why ammonia is one of the ingredients of fertilizer. It is used in elevating stains and tarnishes of soap from tubes, tiles, floors, and even jewelry. Now we will move. This is all about the introduction of acids and bases. I have introduced you some acids, strong and weak acid, as well as strong and weak bases. Now we will move towards corrosive properties of acids. The word corrosive refers to any chemical that will dissolve the structure of an object. The object may be a non-living thing or living thing. They can be acids, oxidizers, or bases. When they come in contact with surface, the surface deteriorates. That means these acids, particularly strong acids, react with the surface and deteriorate it. The deterioration can happen in a minute because acids are highly reactive. For example, when strong acids fall on the surface of silica, generally the surface or tiles are made up of silica. Old tiles or natural tiles are made up of silica, and when strong acid fall on this surface of natural tiles or even on the open surface, open earth surface, then these acids immediately react with the silica present in them and they convert the silica into silica salts, and therefore the structure of that tiles or the surface will destroy. Why acids are corrosive? Because acids produces H positive ion. Strong acids produces large number of H positive ions, and these H positive ions immediately react with the metals to form salts. Because H positive ions are good reducing agent, they accept electron, they undergo reduction, and therefore they are good oxidizing agent. Some acids are highly corrosive in nature, which means that they corrode or rust metals, particularly those metals which are highly active. Acids tend to evolve hydrogen gas whilst reacting with an active metal such as iron, zinc, magnesium that we are using in daily life. They produces H positive ions, as I have shown here. For example, zinc metal, when acid comes in contact with zinc metal, it converts into zinc chloride with liberation of hydrogen gas, and this zinc chloride is soluble in water, and that is responsible for the corrosion of zinc. Again, mostly the corrosion of iron, which is called as rusting of iron. Most of the iron is widely used in most of the things in the preparation of homes or bridges or even rail bridges, or iron is used everywhere. So what problem with iron? Iron is strengthful metal, but the acids are responsible to destroy the iron under the rusting of iron or corrosion of iron, because acid slowly reacts with the iron and convert it into ferric chloride, ferrous chloride, and then when comes in contact with oxygen they convert into ferric chloride, which is water soluble, and therefore the rusting will start on the iron. Here we are observing some bridges and collapse of bridge or some accidents on the bridge because of their collapse is because of the rusting, and this rusting is occur when the rain, acid rain, particularly in that area where there is acid rain. What do you mean by acid rain? In summer season or in normal dry season, SO2 and NO2 gas that evolved from the nature and escape into the atmosphere. When rainy season start, when there is first rain, the waterfall from the atmosphere combine with these NO2 and SO2 gas and produces some acids, and these acids when fall on these iron bridges or iron utensils, they react with iron and corrosion will start that destroy the bridges or utensils. Again, the dangerous part of acid, that their corrosive nature, that when acid, particularly laboratory acids, strong acids like hydrochloric acid, sulfuric acid, nitric acid, when spilled on the skin, fall on the skin will burn, and we cannot remove the effect or the damages of skin by normal, um, uh, uh, what we can say, normal dressing. Because once the skin is damaged, we cannot regenerate the skin. The skin will change its color, and the spot will permanently on that skin is occur. These are some effects of corrosive acids when they fall on skin, maybe the skin of hand or the face. It damages all these things. Now, common corrosive acids are strong acids, sulfuric acid, nitric acid, hydrochloric acid. Some concentrated weak acids are also corrosive. For example, formic acid, acetic acid, phosphoric acid. These are weak acids, but if you are taking these acids in high concentration, they are corrosive in nature. Strong Lewis acids such as anhydrous aluminum chloride and boron trifluoride, these are Lewis acids which are also corrosive in nature. And Lewis acids with specific reactivity, for example, solution of zinc chloride, which is acidic in nature. It is salt, but which is acidic in nature. So it has also a corrosive property. Then how, because of this corrosive property, how can we handle these acids in the laboratory? Strong acids may or may not be organic. They must handle carefully because they can cause several chemical burns or damages. Here I am showing this hydrochloric acid. Concentrated acids are extremely corrosive to all body tissues, especially eyes and skin. While working in the laboratory, we have to protect our eyes and skin because of this corrosive nature of acid. Due to this powerful corrosiveness, acids are highly toxic. However, if handled safely with the right equipment, acid need not be flared. Use acids confidently by learning how to protect yourself, how to use the proper lab equipment, and what to do in the event of spill and other emergencies that will be discussed. Precautions during handling of strong acids and corrosive acids, that you have to wear goggles, gloves, your clothes should be closed, toy shoes and socks, long pants, you have to use long pants, face shield. If not wearing goggles, you can use face shield, neoprene apron that you have to use in lab and lab coat. Chemical spill kit should be there, and no contact lens. You don't have to use contact lens while working in the laboratory. This is the we are discussing some method in short. While first you have to protect yourself by wearing lab coat and apron, which is made up of cotton, because cotton are somewhat less reactive towards the acid. Don't use a terracotta or some other clothes. You have to use coat made up of cotton. Then protect your eyes by using safe goggles that I have shown here. These goggles are different than the normal spectacles. Use the gloves. Use acid resistant gloves. Generally these acid resistant gloves are made up of nitriles or butyl rubber. These are polymer. These protective gloves should wear during handling of the acids in the laboratory. Suppose in case if you are contacted in with strong acids, then you have to use some emergency shower that I have shown in first figure. Then eye wash station should be there in the laboratory, and lab spill kit should be there in the laboratory to protect after the effect of to protect yourself after the effect of these strong acids. While handling the strong acids, you have to educate yourself on what to do in the event of a spill. Here in the first figure, when acid, the container of acid get down and broken and acid spill on the surface. So in that case, what to do? When chemical or acid spill on surface, you must act quickly without panicking. If you spill acid, spread sodium bicarbonate, that is baking soda, on the spill area. Clean it up with a cloth. Afterward, dispose the clothes. If the acid touches your skin, wash it thoroughly with water. Do not put sodium bicarbonate on your skin because sodium bicarbonate is corrosive to skin. You can spread sodium bicarbonate on the surface because the corrosiveness has no effect on the surface. But if you use sodium bicarbonate on our skin after spilling acid, the sodium bicarbonate itself has a corrosive property. Then using proper lab equipments. Here in our lab, different equipments are there. It is used to handle the acid. Use acid compatible containers. There are wide variety of materials used for the laboratory container, which are made up of PVC or low density polyethylene polymer or polypropylene and many others. For example, bromic acid at 10% to 50% can be safely stored in low density polyethylene polymer, container of low density polyethylene polymer. Acetic acid must be stored in polyethylene polymer. It is important to refer a chemical compatibility chart to determine best material for your containers. Then, while handling the acids are highly fuming, so you have to use fuming hoods which must be present in your laboratory. Then to store acid, don't use a glass container particularly because glass container are brittle. So mostly try to use the container made up of polymers, PVC. That and the size of container should be proper so that we can store the acid in a proper way. While storing the acids, there should be a proper cabinet in the laboratory so that we not directly come in contact with the acids frequently. Now, method for preparing acid solution, we have to use a diary which is called as material safety data sheet that you should use because it gives us the idea of hazardness of the chemical, and while using that acid you have to note some important warnings, proper protocols and important information about the acids. Similarly as base that we will discuss after some time. Now while preparing you have to use volumetric flasks. The students which are commonly used in laboratory are well known about the volumetric flask. First you have to, if you want to prepare acid solution, first fill the volumetric flask 2/3 by distilled water, then add the required amount of acid to this 2/3 water because if you add acid to water, the exothermic reaction is slower one. But when if you are taking acid and then you are adding water, then the heat evolved during this process is very high that may destroy the flask, or high heat will be evolved that may damage you or harm you. Then after adding requisite amount of acid, make up the volume to required capacity of the volumetric flask. That you have to take precaution while preparing the strong acid solution. Then handling emergencies, your laboratory must contain emergency shower if sometimes acid is thrown or acid affects your body. You have to take wash as early as possible. You have to use the clothes as discussed. If sometimes you are using hydrochloric acid and if hydrochloric acid is spilled on your skin, then you have to use gluconate gel that will neutralize the effect of hydrochloric acid and stop the burn and provide your skin and give you some relief. There should be a medical kit for dressing in the laboratory. Then While handling the chemicals, corrosive chemicals, you have to observe the labels on the container. If this type of label is there, that means you have to handle this chemical very carefully because these chemicals are corrosive. This figure showing some corrosiveness, what effects of corrosiveness of acid on the tissues, the irritant, irritation will be occur, that these figures are showing you. Now these are symbols that I have already discussed with you. These symbols are available on the container of acids and bases which are corrosive in nature. These are the effects of bases. Generally, both acids and bases damages our skin. Like strong acids, some bases are also damage the skin when they comes in contact with our skin. Particularly the burn effect that produces that damages the skin and very irritating feeling will be there that you may or may not tolerate. These are the corrosive properties of bases. Corrosive are immediately dangerous to the tissue when they comes in contact. Poison may have systematic toxic effect. They require time become evident. Generally, corrosive may be called poisons in case of bases, and some substances are there that are both corrosive and poisons. Some common corrosive bases are sodium hydroxide, potassium hydroxide, calcium hydroxides. We are using these bases in daily or almost in our laboratory while performing experiments. Alkali metals in the form of metallic form are also corrosive in nature. Hydrides of alkali and alkaline earth metals, for example, sodium hydride, magnesium hydride, these are corrosive in nature. Extremely strong bases called as super bases such as alkoxides, particularly sodium alkoxides, metal amides, these are very corrosive in nature. Generally, the sodium alkoxides and sodium amides are used in the synthesis of organic compounds. Organometallic compounds like butyllithium, Grignard reagent, these are also corrosive. Fully alkalized salts of weak acids such as trisodium phosphates, ammonia, and concentrated ammonium hydroxide solutions are also corrosive in nature. The strength of corrosive, I have tried to show you the strength of corrosiveness of sodium hydroxide, potassium hydroxide, barium hydroxide, and calcium hydroxide. This is sodium metal. We are kept the sodium metal in kerosene when not in use because sodium metal are highly reactive and when they comes in contact with skin, they damage the skin and form irritating. These are sodium hydroxide, sodium amide, butyllithium. These are corrosive chemicals, and the handling of chemical is same as that of strong acids. That means because of their high pH, they damages our skin, and for that we have to take the precautions same as that of acid. That means you have to use chemical fuming hood, you have to wear gloves, use the utensils as discussed in the case of strong acids. The sometimes inhalation may be toxic, so you have to use this type of utensils. Inhalation hazard exists. Respiration with appropriate cartridge should be worn. These are the cabinets showing you to store the chemicals. Some bases which are not in use or extra bases should dispose in the sewage that in this sewage they get somewhat neutralized and their effect to the human being is somewhat late. But because of this sewage, the soil is affected. That crop may affect because of the disposal of these bases. To protect the skin, you have to wear aprons. Wash your hands, eyes if they are affected. These are some laboratory safety signs. While handling the chemicals, particularly acids and bases, you have to take the knowledge of these signs And if you don't have the knowledge, please contact with the instructor available in the laboratory. These are some safety laboratory signs. While handling the chemicals, you have to very aware about this. Anyway, today we have, in short, we have taken the knowledge of strong acids and strong bases and their corrosiveness. Okay, thank you everyone. Thank you the course coordinator, Harshile madam, head of the department, Dr. Burgade madam, and the principal of our college, Dr. Korpe sir, for giving me this chance and taking my knowledge, sharing my knowledge to you students. Thank you very much and bye bye.